Alright guys, so this is our next question from the previous ZHAT paper, and I know two ways of solving this, so we'll discuss the first method first. It's the conventional way, and that conventional way is one method that we have already used in several CAT questions. I have put those questions in the description, you can check them out as well. And the second method is slightly better, slightly less complicated. So let's start with the first method, the conventional method. The question reads, the roots of the polynomial p of x are the radii of three concentric circles. The ratio of their area when arranged from largest to smallest is. Okay, so one method is we manually figure out the roots of the given polynomial, and for that we use the method of substitution. So let's start by substituting x is equal to 0 in the polynomial. We'll be getting p of 0 as 2 into 0 cube, that's 0, minus 11 into 0 square, that's 11 into 0, plus 7 into 0 is again 0, minus 6 is minus 6. Since p of 0 is not equal to 0, it is minus 6. X is equal to 0 is not a root of the given polynomial. Let's try by putting x is equal to 1 and finding out p of 1. So p of 1 will be 2 into 1 cube minus 11 into 1 square plus 17 into 1 minus 6. This is 2 minus 11 plus 17 minus 6. This makes it 17 gone, that is 2, and it is again not equal to 0. That means x is equal to 1 is also not a root of the polynomial. Let's try by putting x as 2. We'll get p of 2. P of 2 will be 2 into 2 cube minus 11 into 2 square plus 17 into 2 minus 6. 2 into 2 cube makes it 16. 11 into 11 square makes it 44. 17 into 2 makes it 34 minus 6. This is 16 plus 34, 50, minus 44 minus 6 is again 50. 50 minus 50 is 0. Yes, if p of 2 is 0, that means x is equal to 2 is definitely one root of your polynomial. So that's how we figure out the first root of this polynomial. It's a very standard method. We have solved in several CAT questions also. Okay, so after having found the first root, we can find out the other two roots of the polynomial by regular division or synthetic division. If you want to understand these divisions in the detail, and if you're not very much comfortable with these, you can understand them better in my course. I put the link in the description. Now, I personally prefer the synthetic division in such cases. So let's first write the coefficients here, 2, minus 11, 17, and minus 6, and divide them by the first root we have found, which is 2. Now, here on it's very easy. Write down this 2 here. 2 into this divisor 2 gives me 4. Minus 11 plus 4 is minus 7. Minus 7 into the divisor 2 gives me minus 14. 17 minus 14 is 3. 3 into the divisor 2 gives me a 6. Minus 6 plus 6 is 0. And guys, this has to come out to be 0 because this is the remainder you get when you divide the polynomial by 2. So since x equal to is the root of the polynomial, the remainder should be equal to 0. Now the other coefficients are 2, minus 7 and 3. They are the coefficients of x square, 7 and the constant term respectively. So p of x can actually be factorized as the first divisor x minus 2, and the other part we are getting the quotient as 2x square minus 7x plus 3. Now we need to figure out the roots of this particular polynomial. For that, the first root is already known to us, and that is 2. The second part of this expression is a quadratic expression, and for a quadratic expression which can be factorized, we have a quick shortcut to find out the roots, and for that you can check out my course link. I have explained that in detail. So the roots of this particular quadratic equation are 2 into 3, 6, and minus 7. So minus 6 and minus 1 are the two factors. Change the signs and divide by the coefficient of x square. The roots are basically 3 and 1 by 2. So the roots of this polynomial are 2, 3, 1 by 2. From largest to smallest, if I write the roots, they will become 3, 2, and 1 by 2. They are also the radii of three concentric circles, guys. So if radii are 3, 2, and half, the areas are pi r square. So pi into 3 square is 9 pi. Pi into 2 square is 4 pi. And pi into half square is 1/4 pi. These are the areas of the three circles in question. The ratio of their areas will be 9 pi is to 4 pi is to 1/4 pi. Pi gone everywhere, and multiply by 4. 4 nines are 36. 4 fours are 16. 1/4 into 4 is 1. The ratio of the areas is 36 is to 16 is to 1, and that is your D option very clearly the answer to our question. So this was one way, the conventional way of solving our question, where we actually factorize the given polynomial, finding out one root by brute force, and basically finding out the other two roots. That's how we solve. Okay, so let's look at the other way of solving the question, guys. Now, guys, the other way of solving our question is a concept that we have again studied in CAT, the sum and product of the roots of any higher order polynomial. For a cubic equation, guys, the sum of the roots is minus the coefficient of x square upon the coefficient of x cube. So suppose I call the roots as alpha, beta and gamma. The sum of the roots alpha plus beta plus gamma should be minus of minus 11 by 2. That's 11 by 2. Similarly, the product of the roots alpha into beta into gamma should be minus the constant term upon 2. Minus of minus 6 is 6 upon 2 will give me 3. So now I have these two conditions here, and using these two conditions I can quickly get my answer. Let's see how. The options give us the ratio of the areas. So if you want to find out the ratio of the radii, we'll take square roots. Now let's take the first option. As per the first option, the ratio of areas is 6 is to 2 is to 1. So the ratio of radii will be root 6 is to root 2 is to 1. Okay, this is the ratio. Let's call the radii as root 6x, root 2x and 1x. Okay, now if you observe carefully, their product should be equal to 3. Now guys, without solving in detail, we can observe that x cube will be having a root sign, some square root sign. So x will obviously not be a rational number. If x won't be a rational number, the roots are not rational. And then their sum can't be 11 by 2. So obviously option A is ruled out. You can observe a similar problem in the C option, guys. In the C option, the areas are in the ratio 16, 6 and 3. The ratio of the radii will become 4, root 6 and root 3. So the radii will be 4x, root 6x and root 3x. Same problem. If you take the product, x will obviously have a root sign. So x won't be a rational number. Thereby sum can't be 11 by 2. So option C is also ruled out. If you look at the B option, the ratio of the areas is 9 is to 4 is to 1. The ratio of the radii becomes 3 is to 2 is to 1. The radii will be 3x, 2x and 1x. I have a similar problem now. If you multiply these three, I'll get the product of roots is 3. As per this logic, x cube should be 1 by 2. If x cube is 1 by 2, x will be 1 upon cube root of 2. Again, not a rational number. So the roots won't be rational or the radii won't be rational numbers. Thereby the sum can't be 11 by 2. Option B is ruled out. So now it's either D or E plainly. As per option D, the ratio of areas is 36 is to 16 is to 1. The square roots are 6, 4 and 1. This is the ratio of the radii. Take the radii as 6x, 4x and 1x. Their product should be equal to 3. So 6x into 4x into 1x is 3. 3 ones are 3 twos are. I get 8x cube is 1. Taking cube roots on both sides, I will get 2x is equal to 1 or x is equal to 1 by 2. If x is equal to 1 by 2, the radii are 6 into 1 by 2, 3. 4 into 1 by 2, 2. 1 into 1 by 2 is 1 by 2. Observe that this is exactly what we had got from the previous logic, the previous approach. So we get the radii as 3, 2 and 1 by 2. And naturally their sum is coming out to be 11 by 2. So yes, this particular value or this set of values satisfies all the conditions, and thereby our answer is option D. The ratio of the area should be 36 is to 16 is to 1. So I think this is a slightly better method. You don't need to figure out the actual roots of the given polynomial. You can straight away eliminate the A and C options. A slight mathematical jugglery with the B and D options will give you the answer as option D straight away. The answer is option D.